Morning all of you. Now I am going to discuss about multiplexing. So what is the meaning of multiplexing? Multiplexing means it is nothing but the sharing of a medium or bandwidth. So that means there are several number of inputs. So each input will need a channel generally. Each input requires a channel to be transmitted to the some other place. So for that, so for every input, it requires that many number of channels means it is cost very much costlier, and also the and channels required are also more. So instead of using these many number of channels, we can use a single channel to transmit all the inputs. Is nothing but the multiplexing. That means all the inputs are mixed up here into a single channel, and all these are using the same channel. Instead of mixed up, you can all these inputs are using same channel to send to the some other place. Is nothing but the multiplexing. So that means it is the sharing of a medium or bandwidth. And also it is the process in which multiple signals coming from multiple sources are combined and transmitted over a single communication or physical line. So multiple inputs coming from multiple sources are combined and transmitted over a single communication channel is nothing but the multiplexing. After multiplexing, wherever you are receiving the data, there you need to use a demultiplexer here. So demultiplexing means the single the combined input, the combined signals are converted into different number of outputs so that they are delivered to the different channels. That is nothing but the demultiplexing. So here you are using n inputs are given to the multiplexer. It is given to a one. It is converted into one channel link. So from this here it is receiving n. At the here demultiplexing takes place, and n number of outputs are obtained here. This is the multiplexing. And what are the different types of multiplexing? Different types of multiplexing means here there are two types of multiplexing. One is frequency division multiplexing, the other one is time division multiplexing. Under the time division multiplexing, so here the time is going to be divided here. That means suppose I am considering here 4 channels. On the first channel there are A, B, B, C, second channel B, B, third channel C, C, fourth channel D, D. Like that there are some 4 number of channels, 4 number of inputs are there. These 4 number of inputs are to be transmitted here without losing any data. Okay. So these are connected to a multiplexer now. So what does this multiplexer does is it will collect the data and send. It will allot the for each channel. It will allot some amount of time that is to be transmitted. Suppose here initially this D comes first, and next C, next B, next A. Like that, all these are transmitted, are given some amount of time. After all the inputs are over, again the repeated to the last channel, last input D C B A. So D C B A, D C B A. That means fourth channel, third channel, second channel, first channel. Again after that, again fourth channel, third channel, second channel, first channel. So like that, the data is going to be transmitted to the receiver. Okay, that means each input is given is allotted certain amount of time without changing in the frequency. The bandwidth remains same here, but only it is doing is the time is going to be divided here. So each input is given certain amount of time, so that in that time it is allowed to send the data. After that time, the next input will use the next input is giving the time, so that next input will transmit the data. Likewise, after completing all the inputs, again it repeats. It is going to the again next first channel. Like that, process of the process. It will process the data one by one by using certain amount by dividing the time period. So after mixing up, it is given to the channel so that it is given to the demultiplexer. So what does this demultiplexer does? It will divide the combined data and it will be dividing to the as usual data. That means those number of outputs, how many inputs are there, those number of outputs should be there here. So it will divide it to the different outputs here, so that it will place on that specific output channel. Okay, so that we will not lose any data here. That is about the time division multiplexing. Okay, so this next one is frequency division multiplexing. So in the time division multiplexing, we have divided the time with the frequency constant. Whereas in the frequency division multiplexing, we will divide the frequency with keeping the time as constant. Okay, bandwidth, we are going to divide the bandwidth. Suppose I am considering there are n number of inputs are there. So these inputs are coming from n number of transducers. So here n inputs are given to the transducers. So this transducer will sense the signal and it will convert to the particular electrical signal. So each input will be having a specific, will be given a specific amount of frequency. Suppose channel 1 is allotted with the frequency 1 and channel input is given with to F2 and input 3 is given the frequency F3, 4 with F4. Likewise, N is given with Fn. So all these frequencies are given to the summer here. Summer is nothing but the multiplexer. So what does this multiplexer does? It will combine all the frequencies and it will mix into a single frequency and it will provide it to the transmitter. So this transmitter will transmit the data onto the channel through the antennas. This is the transmitting antenna and this is the receiving antenna. From the transmitting antenna to the receiving antenna, it will receive the data and that data is received by the receiver. Now here again you need to use the demultiplexer. So demultiplexer means you need to divide the data. Divide the again data into by using separate frequencies here. So that means F1 has to be gone to F1. So channel 1 input has to be gone in the F1 and channel 2 on F2 and channel 3 on F3, channel 4 F4. Likewise, N inputs has to be gone under Fn. So that is again from that frequency is used with the output 1 and F2 frequency is used with the output 2, F3 with the output 3, F4 with the output 4. Likewise, N channel is given with the output N. So that means n number of inputs are given here. N number of inputs are using n number of frequencies so that you are obtaining n number of outputs here. So that means here you are dividing the input, you are transmitting the data based on the frequencies here. So based on frequency you are transmitting the data and you will be receiving the data here based on the specified frequency. Okay, these multiplexing everything are time division multiplexing or frequency division multiplexing are used in the DAS, that is data acquisition system, that is in the while using the transmitting the data from remote areas to the present the area which is accessible. So in this one, from this we can conclude that the database systems are complex, difficult, and time-consuming to design. So DAS is is taking too much of time to design, and here you are using the hardware and software which is having a initial startup costs are also high. And also if there is any damage to the database, that would also affect the programs applications which are using the database. And also this extensive the costs which are used for maintaining the database is also more, and also initial training is required for the programmers who has to be work on that database. So no one is aware of the database how they need to use, so they need to be given an initial training for all the programmers and users. Okay, this is about the uh, DAS and multiplex systems.